success to be able to have that huge score. So here we go. Volume by washers. F of x, g of x. Status. We learned how to find the area between two curves, did we not? And it was cool, wasn't it? Now what we're going to do is we're going to take that area that we found between the two curves, and what do you think we're going to do with it? Rotate it around the x-axis. Looks like a peach ring, right? Is that what you said, Grace? Or washer? Yep. Okay. If you rotate it around, you can see that you're going to get that three-dimensional shape that we got yesterday. Sometimes we describe it as cones. Sometimes we describe it as football. Sometimes we describe it as half of a ham. Doesn't matter what it is. At this time, it's going to have a hole directly through the middle. Have a hole through the middle. So what we have to do is we got to come up with a way to figure out the area or the volume of this washer. Do you remember from back in geometry, or maybe some of you suppress those memories, how do we come up with the area of a washer type shape? I think Chris is right. Pi times big R squared minus little r squared. So which function represents the larger radius? F of x. Which function represents the smaller radius? G of x. Okay? And what's the width of the original rectangle that I drew? Dx or dy? Dx. So therefore, you can see that the area or the volume of this washer is pi times f of x squared minus g of x squared dx. That's the volume of one washer. How many washers do you want? You want an infinite number. Slap on an integral symbol and go from A to B. That's the formula. Probably should have written in the box, shouldn't I? Oh, well. Let's draw an arrow. Just there you go. Let's try an example. Wait, you didn't? I'm sorry. Yeah, that cheating thing just. Yeah, what? And again, part of what upset me about the situation is again how people seem so outraged by it. But I wonder how many people would actually do the same thing if they're given the opportunity. And so I was very disappointed. I was very disappointed in the SAT officials. That's what I was most disappointed by, that they would be willing to do that. Okay, here we go. This is a good classic example. And when I say classic example, that means that as you look at just about any type of textbook or many college teachers' classes, you're going to see this type of example given. Y equals x squared and x equals y squared. We're going to look at the area bound between those two. And it looks like we're going to rotate it around the x-axis. So what does y equals x squared look like? X equals y squared. What does that look like? Sideways parabola. Can you see the area that's bounded between the two functions? Yeah, it's that little sliver. So, what I'm going to do is I'm going to actually, you know, use my handy dandy eraser guy, and I'm going to try to just draw that section. I'm going to try to make it look a little bit more pronounced so we can see it better. Everybody agree that that's what I'm looking at? Yeah. Yep, I kind of zoomed in on that. Okay. All right. So there we go. So the question is, as you rotate this around vertically, we're going to draw these vertical rectangles. What's the width of that rectangle? Dx. As you rotate it around, what shape are you going to get? A washer. Nope, I try to do it to help you visualize it. It's the biggest criticism I get from students during this time is that they say they can't visualize it very well, and I apologize for that. Um, I'm doing the same things my college instructors did and my high school instructors did, and this is this is how they'll draw it on the AP exam. In fact, the AP exam would love if you showed it like this in your free response. And so I can look back at the 46 exams last year, and it's great when I look back and actually see there was a washer problem on the exam last year. Um, and so what I actually do is I take the washer and I draw another one out here. And I know that this to some people seems redundant, but this is actually really helpful in the long run. As I draw this washer out there, it's going to allow me to insert some important pieces to it. Number one, the width is dx. Is everybody okay with that? The second thing I'm going to do is I'm going to draw the axis of rotation. What is it rotating around? X equals 0. I'm sorry, y equals 0. And then I'm going to draw this part right here. What is it that makes up that part of the washer? What is it that makes up that part of the washer? X squared. Does everybody agree? X squared makes up the lower part of the washer. Y equals X squared. And then what makes up the top part of the washer? X equals Y squared. So we have one issue before we start working through this. Does anybody notice what the issue is? Exactly. This is a dx problem. We know it's dx because we determined that as the width. Therefore, everything, now as we move forward, it has to be in terms of x. Well, I have x squared, but what would I do here to come up with the x? Square root. So I have this goes to y equals the root of x. It is not because we know it's positive over here. It would be negative if you had the underneath portion. So suppose that you were given these. You're given x equals y squared and y equals negative x squared. The parabola is going down. Then you would have to use the negative root of x. I haven't ever seen them do that to you, and so I wouldn't worry about that. But good question. Okay, there we have it. So I have a washer. I'm going to do pi times big R squared minus little r squared dx. What is my big radius? The root of x. So pi times, what's the root of x squared? X minus x to the fourth dx. That's the volume of one of the washers. How many do you want? An infinite, so we slap on the integral. What are we missing at this time? Bounds. How are you going to determine the bounds? Some are equal to each other. Okay, Rebecca just gave a look right there, like her toenails were being pulled out with a needle nose pliers. Yeah, it was a painful look. It's not that bad. What's that point? 0. Anybody know what this point is? 1. Now, I'm going to show you guys. Would you all agree that 1, 1 is a point that is on both of those graphs? Okay, that's the easy way to do it. If you actually wanted to work through it, what you could do is do this substitution where you know that, you take y is x squared, and so you'd substitute it in, and you would get x equals x to the 4th, right? And then you would subtract the x. You get 0 equals x to the 4th minus x. What do you factor out? X times x cubed minus 1. Can everybody see you get 0 and 1? Okay. So that's another way to look at it. It's easier if you just recognize, hey, it goes through 0 and 1. Okay. It doesn't sound very mathematical, but it sure works. All right, antiderivative. What do you got? X squared over 2. X to the 5th over 5. Thank you. I left that off to see if anybody would notice because I've made the mistake many times. Don't forget about pi in that situation. You plug in the 0, you get 0. Plug in 1, and you get 1/2 minus 1/5. Or 5/10 minus 2/10. 3 pi over 10. What do you think? Thank you. It is cool. It's amazing. Look at what you guys are doing. Just look back at the stinking problem. Like, that ain't for weak-minded people, is it? Like, you show that to mom and dad, they say, yeah, I'm gonna pay $500,000 to write off your SAT score to get you in the school you want to go to, right? You're like, because I think my kid's pretty smart. But unfortunately, it doesn't work like that. So, yeah. All right. Let's try a different one. Find the volume of the area between y equals 1 over x, x equals 2, and y equals 2, rotated around the y-axis. What's different about this one? It's rotated around the y-axis. That sounds extremely challenging, doesn't it? And this is our last example for the day, okay? Yep. Yes, you guys are intelligent mathematicians. You guys are smart people. I'm proud of you for that. I took care of your letter. All right. What do I do? Somebody help me out. What does y equals 1 over x look like? Good. Cole's got it. It's a reciprocal function. What does x equals 2 look like? Clap for him. Thank you. All right. What does y equals 2 look like? Where's the region that you're bounding? Yeah, it's this guy right here, right? I'm going to draw it in blue. Everybody agreed? Now, I'm rotating it around what? The y-axis. So if I'm rotating around the y-axis, do you think I should draw vertical rectangles or horizontal rectangles? Horizontal rectangles. Is the width dx or dy? dy, Lynn? What do you mean? What do you mean draw the picture the other way? I'm trying to work with you here because you could be onto something. Sorry, YouTube. All right. So Dylan asked a really good question, and the question is maybe could you rotate it the other way? And the answer is yes, and that's what we're going to do on Friday. You would be rotating around x is equal to 2, and that's very, very different than rotating around x equals 0. It's much more challenging. Now, I do have some people, they would say, well, what if instead of rotating around the x-axis, or y-axis, what if we rotate around the x? Would we get the same exact volume? And sometimes you do, sometimes you don't. It depends on whether or not the shape is evenly balanced, symmetrical, things like that. I would encourage you to not try to go that route unless you're very, very, very confident what you're doing. So you would get a different result if you did that. Very different result. But we are going to do that on Friday. Okay, we've got a washer. Let's draw it. Okay, I'm going to try to draw a good washer. I'm sorry. My daughter, telling me she got some tough news yesterday. Her best friend might be moving. And so they've been best friends since they were in preschool. And so she's in second grade. They sit together every day at lunch, and Tenley is 7 years old, going on 25. That would be Kiera. Kiera's in 8th grade. Okay. Okay. What determines the middle? Y-axis, which is x equals 0. What determines the inside of the washer? It is 1 over x. Y equals 1 over x. What determines the outside of the washer? X equals 2. Is everybody clear? What's the thickness? dx or dy? dy. So that means I have to have a y. I've got an x. So what are you going to do? We got y over 1 equals 1 over x. How are you going to solve this guy? We got cross multiplies to get xy is equal to 1. Then x is 1 over y. Very good. So we got x is 1 over y. So that means that the volume of this guy, right, that you see right here, this volume is going to be equal to pi times what is big R? 2. Squared is 4. Minus, what's little r? 1 over y squared. 1 over y squared. dy. Yeah. This is little r. See it? 1 over y. We square it. This is big R. What's the distance from 0 to 2? 2. Everybody got that? Okay. How many of those do we want? Infinite. We slap on an integral. Let's integrate. Shoot, I need bounds. Oh, man. Got to be y values. Anybody see the top y value that I have? 2. Very good. Yep. How about the lowest y value? 0.5. How'd you get that, Katie? Okay, it just kind of looked like it's between. That's a good idea. Isn't it the intersection between x equals 2 and y equals 1 over x? If you plug in 2 there, you get y equals 1/2, don't you? Yeah, so we're going, so you got to look at your original area. Your original area is this guy right here, right? So we're looking at the y values of that original area. So the top is 2, and then the bottom is the intersection of x equals 2 and y equals 1 over x. So we plug in 2 there, you get 1/2. So that tells you that that's the bottom. Katie did a good job of just kind of looking at it and say, well, if I had to make a guess, it'd be 1/2. But that's how we actually calculate it. We all good? Use a lot of your math skills over the years to do this stuff, don't you? Yeah, that's what makes it really cool. Ties everything together. All right. What now? And what's the antiderivative for? 4y. What's the antiderivative? Negative 1 over y squared. Positive 1 over y. Is that cool? Is that cool? It's really neat, isn't it? Evaluated at 2 1/2. So plug in 2. I get pi times 8 plus 1/2 minus 2 plus 2. So I've got 8 minus 4, which is 4. 4 plus 1/2 is 4 1/2, or 9/2. 9 pi over 2. Isn't that cool? Look at that shape. Look at that mathematics. Man, you got to be proud about that.